and welcome to my presentation. In this brief video, we'll be covering the concept of the linear probability model. To begin with the definition, a linear probability model is a special case of binomial regression model. Here, the dependent variable for each observation takes values that are either 0 or 1. This model is a pretty simple one, and allows it to be fitted by simple linear regression. Now you may be asking yourself, what is linear regression exactly? Basically, it's a number of independent and dependent variables. When these variables are collected, they can be plotted along the graph, along the x and y axes, and certain trends may be made clear. Often a line of best fit can be drawn to show further patterns. Okay, great, we've defined the topic, but why is this important? What purpose does this have in my life as an engineer? Well, observing trend lines may help us make predictions about the future, so long as reliable data is utilized. One such example can be seen on the next slide. This graph shows the relation between the number of hours testing a bridge versus the number of bridge collapses or complications. From this graph, we can see a strong negative correlation, and we can interpret that as the number of hours spent testing increases, the number of bridge collapses decreases. With that in mind, we can then make decisions on how to build more stable structures. Along with the negative correlation in this example, there are also positive correlations which can be seen in the next two. The first is the relation between the number of field tests versus the number of successful rocket launches. As the number of field tests would increase, so would the number of successful launches. This demonstrates a strong positive correlation, and with this, we can then determine that the number of field tests we need to perform if we wanted to be successful. The second example yields similar results. It shows that as the time spent designing a machine increases, so does the machine's level of output. From this example, we can conclude that if we want to build the most productive machines possible, it's going to take some time to design. These examples show that we can draw conclusions from trend lines to give us greater chances of success rather than choosing a plan at random. To wrap this video up, I would just like to emphasize the importance of understanding the linear probability model in real-world scenarios, as this can greatly impact our future. Utilizing these concepts as engineers will save us from failures in many cases. Consider collecting data and observing trends before certain decisions are made.